Hello everyone, welcome to my YouTube channel. So in this tutorial, I am going to explain how to perform molecular dynamics simulation of protein ligand complex. So in last tutorial, I explained how to perform simulation of only protein in water environment. But in this tutorial, extra ligand molecule will be added within the active site pocket of protein molecule. The main problem with protein ligand simulation is that GROMACS has inbuilt capacity to generate the protein topology, but it cannot generate the ligand topology. Okay, so we need external web service like CGNFF or ProDRG or LeakPerGen. This kind of web service to generate the ligand topology, and then we add ligand topology with the protein topology to make a system, and this can be created manually or one CHARMM-GUI, that means CHARMM graphical user interface web service is available through which we can generate this system as input for MD simulation. And this CHARMM-GUI is very useful, and you can easily create the protein ligand topology and the complex and the system for MD simulation. So in this tutorial, I am going to use CHARMM-GUI for generation of the protein and ligand topology. And finally, this input will be subjected to MD simulation using the GROMACS. Okay, okay. So let's start. Uh, so this is the tutorial folder, and here I have kept the protein ligand complex. It's a single PDB file where both the protein coordinate and ligand coordinate is present as a complex. Okay, and this protein ligand complex will be used as input for CHARMM-GUI. So type in Google CHARMM-GUI, then you have to sign up and log in. Okay, so then this option input generator, click here, then you will be prompted for a login. Click in this option solution builder. Okay, now you have to upload your protein ligand complex PDB. So I have selected this option PDB and choose file. In tutorial folder, I have kept this protein ligand complex PDB. I'm uploading it, and just select this option check or correct PDB format. If there is any error, it will automatically be corrected. Then click next. Now you can see it's showing that there are two parts, that means protein chain and heteroatom. Heteroatom means the ligand. Okay, so we have to select this heteroatom because we want to generate topology for both protein and ligand. Then click next. You can see now we have to generate the topology of ligand molecule. Okay, so here reading heteroatom chain residues, that means the ligand, it's saying it's ligand. Okay, so rename to 1, then click here CSML search because we want to generate the ligand topology. So you can see no residues in charm phosphate, that means the charm phosphate cannot identify this ligand. Okay, so we can generate the ligand topology from the PDB coordinates. So I have selected here, click if you want to parameterize ligand force field using PDB coordinates, and we can select next. So then one option will appear here, the PDB coordinates. Okay, so from the uploaded PDB coordinates, we can generate the force field for ligand. But sometimes due to errors in the ligand structure, it do not work. So you can, in that case, you can use HDF file of that ligand, because usually the HDF file are better. They are usually error free. So you can upload HDF file of that ligand, and I am uploading here the SDF file uploaded from the choose file. So I am choosing the SDF format of that ligand. Open. Now I have opened the SDF file. Then keep all the options same. Then click next. Now CHARMM-GUI will generate ligand topology along with the protein topology. Now our job has been finished. So this is the step 1, and topology for the ligand has already been generated. Now we have to select the box, simulation box. So it will be rectangular in shape, or you can choose octahedral. So I am keeping it rectangular, and the edge distance 10 angstrom. Okay. Now we have to add ion for neutralization. So here as default it's potassium chloride, but I am selecting here sodium chloride, and at simple ion type. Now it's sodium chloride, but when we neutralize, the total charge of the system will be 0. So I am keeping here 0. Then calculate the solvent composition. To neutralize the system, now total 1 sodium ion is required. Okay. Now click on next. So you can see here all the steps are automated. Okay, the generation of the simulation box, adding ion, that means neutralization, force field generation, topology generation, these are automated. Only the last few steps, that means minimization, equilibration and production done, will be done through command line interface using the GROMACS software. Okay, but the early stages can be done through CHARMM-GUI. So this CHARMM-GUI uh, save our time and labor to generate the protein ligand topology. So TIP3 water model is used in CHARMM-GUI, and you can also select the different force field model which you want to use, and using the same protein ligand complex you can generate input for different MD simulation software like GROMACS, NumD, AMBER, CHARMM. Okay, the job is now finished. Now this is the box type and the system size. Okay, now we have to add the periodic boundary condition. So I am keeping it as default and click next. Now next step, we have to select the force field. So I am selecting here CHARMM-36 force field, which is good for protein ligand complex simulation, and I want input for the GROMACS. You can generate input for other MD simulation software packages, but I am going to generate input for only GROMACS. Okay, then equilibration equilibration will be done in NVT ensemble, and for dynamics main production done, it will be NPT ensemble. And temperature I am selecting here 300 Kelvin. So these are the parameters or options. Click next to generate the inputs, and this is the final step. In this step, input for three major steps like minimization, equilibration and production run will be generated. So .gro file, all kinds of MDP file and topology file will be generated as input, and this file as zip folder we can download from the CHARMM-GUI web server. Then through command line we can run the minimization, equilibration and production run, simply like we have done earlier with the protein simulation, protein in water simulation. So I will be showing you the command line for these last three steps. Okay, So the input files have been generated and you can download it. So clicking here, download this option. Okay, if you click here, these input files will be downloaded. So I have already downloaded it and saved it in my tutorial folder. So this is the output of CHARMM-GUI, which will be used as input for GROMACS MD simulation software. So let's extract it. All the files will be extracted and let's open it to check what are the content. Okay, so go into this folder GROMACS. Okay, these are the input files, and within this topper folder, that means topology and parameter, you can find the topologies of different components. Like this is the topology for protein, this one for ligand, this is the force field topology, this is for water topology, and this is for ion topology. Okay, and this is the index file, and this is the .gro file, the GRO file of protein ligand complex, and these are the three MDP file, and this is the main topology file. If you open it, you can see within main topology only the ITP files, name of the ITP files has been mentioned. So when GROMACS open this and read this topology file, it is directed to the topper folder. You can see this is the topper folder, and it's written here include force field ITP, which is present within the topper folder. So I have already shown you that these ITP files are present within this topper folder. So automatically these ITP files will be included from this topper folder. Okay, and these are the MDP files. So you can change parameters of MDP file as I have already explained in my previous tutorial. Like in case of production run, integrator MD steps are included here. You can increase this step to increase the simulation runtime. Okay, if you multiply it, so as default it is 1 nanosecond, but if you want to simulate for 100 nanosecond, then you increase here 20 more, so it will be 100 nanosecond. Okay, so temperature coupling, pressure coupling, that means here V scale have been included. This is the thermostat. Okay, so you can change this MDP file and save, you can save. So now this is the .gro file, this is the index file, this is the topology file for protein ligand complex, and these are the three MDP files. All these inputs are present, just you have to run three steps in GROMACS through command line. In my command file, command text file, I have written the command line to run this step. Okay, so I will attach this command file with the YouTube description box. You can download it from here, and I am opening it to show you the command line, and I will explain each part. Okay, these are the commands for last three steps. Okay, so for running simulation, first of all you have to enter the folder into terminal. So these are the content. You can see in case of minimization, first of all we have to generate a run input file, that means TPR file. Okay, for that this is the command gmx grompp. Okay, so and here we are using this MDP file which is already saved. Okay, the name of the MDP file is step 4.0 minimization. Then we are going to use the .gro file, and name of the .gro file is step 3 input. This is the step 3 input .gro file, and we will update the topology file. This is the topology file topol.top, and as output will obtain step 4.0 minimization.tpr, and this is for index file. So this is the output TPR file. In next step, this TPR file will be used for MD run, that means for minimization. Similarly, for equilibration step, this is the MDP file, step 4.1 equilibration.mdp. Step 4.1 equilibration.mdp is present here, and we will use the step 4.0 minimization.grow, which is output of the previous step, that means minimization. After minimization, you will get step 4.0 minimization.gro. So this will used as input. Okay, then we will update the topology and we will generate a TPR file, step 4.1 equilibration.tpr. This file will be used for MD run for equilibration step. Similarly, for production run, this is the MDP file which is present here, step 5 production.mdp, and .gro obtained from the previous step will be used here as reference structure. Then a run input file with name step 5 production.tpr, and this TPR file will be used for production run. So these are the last three steps which we have to perform through command line interface in GROMACS. Okay, to understand this protein ligand complex simulation, I suggest you watch my previous tutorial on protein simulation, protein in water simulation. There I have explained all the steps thoroughly, and in Linux command terminal, in Linux terminal, how to use this command line. But in case of protein ligand simulation, I have used CHARMM-GUI, because ligand topology we should generate through CHARMM-GUI or other web services. So we can also generate manually this topology of ligand, but CHARMM-GUI is very useful. You can easily generate protein ligand complex topology and save your time. Okay, but in next video or in upcoming video, I will try to upload tutorial how to manually generate protein ligand complex topology and how to simulate manually. Okay, so that's all for this tutorial. Thank you for watching.